Welcome to your science, everybody. So we're going to do the Temp Lag Lab here, which looks like a terrifying amount of data and it's going to be scary. Don't panic. It's not bad at all. Should be a pretty quick one, pretty quick 30 out of 30, honestly. What is a lag? That's kind of the big thing we need here. What does it mean to lag? Like, think about it in terms of your internet, or if you were trying to do something with video on one of these Chromebooks and it like skips. That's a lag. Or if you're playing online games. I used to have really like slow internet at my house. So try to play Fortnite or something, you shoot somebody. By the time that you hit the button, by the time the internet gets that to the server, that dude is long gone. You know what I mean? There was a lag, a delay. How about that? What we're going to look at is this lag or delay between peak insolation, we should know what that is. That's like sunlight, and temperature. Now, we've all done seasons, right? We've all made it through that. Let's think about what we learned back then. We learned that the summer solstice, June 21st, right about here, is peak insolation. That's when the sun is at the highest angle in the sky. It's out for the longest amount of time. So Pulaski would gather the most energy on that day from the sun. But ask yourself, so is that the hottest day? Is June 21st the hottest day of the year? Not really. When does it really get hot in the summertime here? Opposite. We learned that December 21st, the winter solstice, will be the day where there's the least amount of insolation reaching Pulaski. The sun's at the lowest angle, it's out for the shortest amount of time, so not as much hits. But is that the coldest, or does it get colder later? Is there a lag or a delay? That's what we're trying to get at here. Honestly, that answers all those questions. So, like, if you got to do these questions later and you say, I don't remember, come on back to the beginning of this video and check them out. And then down here, once you're done with all the graphing, you'll just have to explain kind of what that lag is, what that delay is, how it works. Try to explain it to somebody as if um, you have to explain to them, like from scratch, what this idea of temperature lag is. When is the sun the most intense? When does it get hotter? Why does that happen? This little mini article right here can help a little bit too. In terms of the nuts and bolts of the lab, although this again might look intimidating, don't worry about it. It's going to be pretty easy. You're going to fly right through it. So the x-axis, this graph should look familiar too. We used this before on this apparent size of the sun lab. I stole the same graph. So we've got all the days of the year, and although I have all of the data here for the whole year, let's just do the days that are listed here. So you don't have to like plot every single day and drive yourself bananas. We'll do it about every 10 days like is listed on this graph. So what is it on January 1st? What is it on January 10th? What is it on January 20th? And so on. This may be the first time we've done one of these. We're going to have two different lines for two different sets of data on one graph. And why that's cool is what it will be, cool to me, what it will be is you'll have one for insolation. You'll have one for how much sunlight's hitting Pulaski. And then you'll have another one where you use this side, where you use temperature, and you see what the temperature is on that day in Pulaski. And when you look at those two, the lag will show up. It'll be evidence that our peak sunlight and our peak temperature are not on the same day. There's a gap, there's a delay, there's a lag. All right, so how do we do it without driving ourselves bananas? What I did when I made this was I went to this website that I think is designed for people that put in solar panels, and it output data by the year by what was detected. And I did 10 years worth of data, and then used Excel to like line them all up and make an average out of all of that. But because of either like equipment not working, or maybe they don't do it when it's cloudy, or who knows, there's some days that did not end up having any data points, but that's okay. We can still figure out what we should do here. Month, like that's month of the year, right? One is January, two is February, and so on. You got the whole year listed out. Month 1, 2, 3, 4, 5, up to 12. Day will be January 1st, January 2nd, January 3rd, and so on. Insolation, that's how much energy is hitting Pulaski. It's a strange unit, not one you need to panic about. Kilowatt hours per meter squared per day. So how much of energy that's measured in that unit hits a box that's a meter by a meter, take a meter stick, meter by a meter, in a given day. I'm not saying that I have any idea of what 2.3 of those means. That doesn't really make, it's not a number that makes sense to me, but it'll allow us to compare, like, when is there a lot of energy coming in, when is there not much energy coming in. The graph will be very easy to figure out, even if we don't know exactly what these numbers mean. So let's do a few. January 1st, what is the insolation? January 1st, it is 2.2. So we're going to come down here, do the same old thing with Cami. Put it on maybe about size 6. I don't know what color you want to do for insulation. 2.2, I'd say is right about there. Done. Move on. January 10. It's also 2.2. Easy peasy. Boom. January 20, and so on. And just keep on doing that. Now, you'll eventually at some point get to one where, like maybe this will be one. Is March 10th one of our dates? Yeah. So, like when you get to March 10 or any other, it happens a couple times in this lab where, there's no data. And again, who knows? That equipment wasn't working. It was cloudy. Who knows what happened over the course of those 10 years? March 10th every year, it didn't work. Okay. Are we clever enough, though, to figure out about what it might be? Well, on the 9th, it was 5. On the 11th, it was 4.9. So maybe somewhere right about there, and that'll be good enough. Between 5 and 4.9 on March 10th. So I'm thinking right about there-ish. Somewhere around there is what it should be. Because it was there the day before, there the day after. We're clever enough to do that. Now, I'm not saying skip all these. Go back and make sure you do those. But that's an example of what you'll do when there's a blank. Cool? What about temperature? Let's do those. I'll do a couple of those too. January 1st, it's negative 0.3. Now, you're going to want a different color for temperature. I'll use blue. You don't have to. Negative 0.3. Over here, I got 0 right on that dark line and going down, down, down. So January 1st is negative 0.3. That's going to be like barely below 0 right there. January 10. Negative 1.3, a little colder. Maybe right about there. January 20. Negative 2.7, a little colder yet. Negative 2. Maybe right about there. Okay. You'll do all those. You'll connect them with a line. Sometimes we're not quite doing a great job at drawing lines. People are doing great dots, but we're not playing connect the dots very much. So once you're done, change your pen to a smaller size, pick the right color, and play connect the dots. And then you'll have a red line that goes up and down, a blue line that goes up and down, but are offset by that lag. That's really it. Do that. Do those questions, which again, if you're lost on, go back to the beginning of this video. Click submit. Should be a quick 30 out of 30 for you. Good job, everybody. Good luck. Take care.